Hello, are we live? Apparently we are. And then, yes, elapsed time 6 seconds. Seems about right. At least on YouTube side. I've been working on this while you haven't been here. Specifically, I've been rotting around all in the internal opcodes around here and fixing loads of crap with the addressing, and it's still not complete. It's not. It's the addressing is just fuckery. It's awful. Do a picture? Yes, we do a picture with a awful picture of me. Let's close this piece of junk. Whoop. I have here a bunch of pin tabs that will help us, including a very good ROM here that has a log of its actual execution and the state of all of its registers throughout. And when I eventually get all of the functions implemented and somewhat working, I'll start running this and start checking off the log. So far I have used it to identify that the jump was fucked and that the brake was fucked and that pretty much anything was fucked, and then I realized that it was the addressing's fault, and then I spent 4 hours literally just editing this section over and over and over and over and over. And then it dawned on me that I've used the wrong philosophy in my head for when coding this. I might need to change all of this out. I hope not to. I'm hoping that all of the functions that require this weird conditional, or not conditional, but it's like weird addressing where you just grab bytes separately, like literally they're not right next to each other like they should be. They can literally be on 2 different pages of RAM, and you read them as a 16-bit integer, and it's like, what the fuck, mate? And don't even get me started on the indexing here, and especially not like 0 page and anything related to indexing. So yeah. You might have seen this, but you might not have. I don't remember at this point. I don't remember what I've done on camera because, quite frankly, I'm sleep deprived at this moment. But I think last time you saw this, there was 2 numbers after the function, one declaring the addressing mode and the other one declaring the step. That was just awful way to do it, because I need to define it per function, and I don't want to define it 153 times, I think. Potentially up to 250 times for the illegal opcodes that behave strangely. God damn it. Also, I need to figure out how to solve the carry flag and the accumulator register, and to make them work in unison, and to not do bitwise magic in every one of these internal op functions. I would like to create some kind of backbone so I could literally have an abstract object called accumulator. Yeah, maybe that's how I'll do it, and then I'll call accumulator.add. Maybe I'll add in accumulator.subtract, and that will handle all the carrying and overflowing and zeroing and updating of the registers. of the program status register right there and then, so I don't need to call it as I do right now. Within the functions here, I do like a ALU compare. That's like the first helper functions for the program flags I have, and I'm using it all over the place. And at this point, it feels like, I mean, look, I'm literally reusing code here. I should literally just work out some kind of 4 or 3 general functions that, I don't know, affect the what's the proper name of that register? Program flag. It's an S on the end. But yes, that's the story of how this helped me actually get the addressing somewhat working, and I've improved this in a lot of other ways. In terms of ways of life, I have implemented so that if it enters FF land, it just terminates, and I've entered so that if it crashes, it just terminates and prints a bunch of status, and now it actually prints a piece of the memory map if I wish to, so I can see the memory between each step. That's very useful and helpful, especially when you're working with addressing issues. It's like, I remember I was working with, which one was it? Was it the relative one? Yes. Or maybe, yeah, it was the relative one, I think. Or maybe it was the absolute index with x. And it wrote to erroneous places. It was supposed to write from 0x0 to 00 and forward, 3 values, and it wrote to somewhere in the low range, somewhere on 0x 0 to 00, and just way beyond that it was just scattered all over the place. Instead of this, it's just like this. It's like, what? But anyway, I fixed that because, what was the issue? Oh yeah, it's because instead of giving the address, I was giving the read of that address, which was stupid. And it's stupid things like that you do when you're not sleeping correctly, when you're doing big projects like this. So if you're doing this, at least take care of yourself, because you'll get done quicker. Learn from my words, please. What was I gonna do? Yes. As you see, this document is quite long. Like, really long. Currently over 686 lines long. What I'm gonna do is I'm gonna move all of the opcodes into a new file. I'm gonna save this as opcodes. .py, probably. Save. Open the emu, scroll up, identify where all of the opcodes are. Select them all. No, wait. I need the helper functions from this file. Damn it, I need to import the helper functions into a separate file. Well, I'll do that. Opcodes can go in here. No. There we go. That's what I did want. I don't need a class definition here. I'm just gonna from opcodes import star, which is just gonna import everything into local space, so I don't have to change any naming conventions. Yay, laziness. And this we will. So what helper functions do we need? set bit and downwards, I think. All of this, so we need a helper functions file, save as helpers.py. Maybe global, no, helpers. All helpers should be in one file. Let's not fuck ourselves. Ah, I didn't copy it. Shit. Oh. Let's do that, let's do that. Let's make some space at the top because I don't know, I wanted to see what's above the first line for some reason. Just to make sure there's not another line. Bus reads, PC read, S read, all of this shit. Push, pop, peek, read 16, write 16, all of this shit. All of this shit has helper instructions. It's actually, now when I see it, it's a lot nicer to have this like out of the way. Maybe I'll divide this up into blocks. So there we have all of our helpers in one file, all of our opcodes in one file. Now in our opcodes we actually need to import all the helpers. So from helpers imports everything. Does that work? It probably will. And from, let's just be dumb and just import opcodes directly. And from needs to be at the top because Python. From opcodes. Oh shit. Actually no, this is not gonna matter. Import everything. Let's see if it still runs. Also, yes, I was gonna say that I've finally managed to use this space here, this black space, so you can actually read what the terminal is saying, because it's actually sort of working now, so it's actually producing some sort of output. Yes. Helper, it should be helpers. Oh, from dot helpers, from dot opcodes. Okay, relative imports is not the problem as I thought. Where is helpers.py? Where are you located, man? Yeah, it's in the wrong. Why can't I do anything like at all? Oh, select folder. Yes, helpful. Where is my project? Where is my Pythons? For some reason it ended up in here. What direction? Oh. This doesn't... I don't think we're gonna have any... Shit. We need to import it in the class, I think. It just dies instantly. So instead of importing it in here, because we're defining the processor as a class and it expects the functions to be in its namespace, we need to import it in the processor, I guess. Let's hope that works. It fucking does. So here you see the stack at the top there growing, and now it's running some more code and actually popping the stack. And I haven't read up much to know if the 6502/3A02. So if I don't know if the 6502 or if the 3A02 actually clears the stack when it pops. I'm just moving the pointer right now. So, yeah. But let me show you a real kicker here. I'm gonna switch to output from location 0x0 to 00 to 0x03. Sure. And this program is actually pulled straight off this side here, EC6502. And it's actually the stack program right here. So let's go through it, shall we? It loads an X with an immediate. That means it loads the value to load into the X register directly in the opcode, because essentially an opcode is 2 bytes, because you have your operation and within that operation you have your addressing mode, but outside of those 8 bits you also have your parameter that's almost always included, unless you have functions like PHA or PLA, like pushes A onto the stack or pulls A off the stack, that you know what the target of that is and you know what it's going to do. You don't need to give it any parameter. So in that case, the function length is shortened down to 1 byte. The function, what did I say? The opcode is shortened down from 2 bytes to 1 byte, and it only steps 1 to save some program space, I guess, because that was important back in those days. But yeah, so we load X with immediate 0, so we load directly from the parameter, and load Y directly from the parameter. We basically fill our X and Y registers with zeros, and then we enter our first label? Yes, label. And this is assembly language. This is not directly 6502 execution assembly. Actually, it is. It's just that the labels are taken out, and the labels are just used for the branching. So theoretically, you are writing straight memory, just straight down, and the labels are just there to help you identify where to jump to or where to branch or where to IRQ, or where to reset, or whatever. And we enter our first label, so we know where that is, and the processor doesn't see that, so we go straight to TXA, which is transfer X to A, and then we store A at 0 to 0, 0 with index of Y, and I think that's absolute. I don't know. It's indexed with the Y register at least. And then we push A onto the stack, then we increase X, and then we increase Y. Then we compare if what's in the accumulator, we basically take what's in the accumulator and negate it with our immediate here, because the hashtag here tells us that it's going to load the value directly from the parameter and not from the location of the parameter. Two very different things. So we basically take our accumulator, negate it with that, and we do some ALU comparisons, and we push out our we update our flags, like the overflow, the negative, the zero flag. The zero flag is what's used to do most of the branching, by the way, in microprocessors. So we compare it, and directly after that we do a branch if not equal. So we branch, not equals basically checks the zero flag. So if it's 0, A minus B, and it's 0, A and B must be the same. So we branch if they're not equal. So as long as Y is not equal to 10, we're gonna jump back to the first loop. So we're gonna print something to the memory indexed with the Y register 10 times. And then we're gonna not jump back, and we're gonna fall through to our second loop, and we're gonna pull A. Yes, we pull from the stack S, and that gets put into A. I think. Yes. And then we store A at this, basically the same way as above. So we basically do the same thing, but we pull off the stack instead of pushing off the stack here. And we still increase Y, but we don't increase X. And now we compare to 20. And then we branch if not equal again to the second loop. So as long as we're under 20, we're gonna rerun. And after that we fall through into FF land. So, with that said, let's run it. 8, 9, A, B, C, D, E, F, F, E, D, C, B, A, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Enter the FF land, terminating. I think we're on to something, fellas. Yes. When I first saw this program actually run and producing this result, I was kind of ecstatic, to be honest. And now we can basically enter our memory and check all of this. So here we have our output. 1, 2, 3, 4, 5, 6, 7, 8, up to 15, and then down to 1 again. And here we have our actual stack. So you see, I never clear the stack, but I do move the pointer, so I guess that counts, I guess. But we are now gonna run the NES test and see how far we got. Let's compare it to the log and see where we blatantly fuck up and branch off trail. So we start at C00 with this, yes. We jump to, it's a jump, yes. And we move to C5F5, which what we do a load X, yes. we continue on to C5 F7, yes, with a store X. What? Ah, okay, it's referencing the memory locations. I'm stupid. I haven't learned how assembly language references addresses. I know it has something to do with the $sign and the hashtag and the encapsulating and comma registers and crap, and I bet it's simple, but I don't have time to learn that. I'm just trying to make an emulator. C5 F7 with store X. Can we see where it stores X? Oh, it just stores zeros in a bunch of places. I wonder why. According to the documentation, it's... Oh, okay, that makes sense. It outputs the last failed tests into memory location hex 2 and hex 3, not... I got confused as fuck reading this. I was like 0C 000H, and then I remembered H is not in the hexadecimal character set, so exclude that and just assume 8 stands for hexadecimal. And then I was like 0C 00005. What? And then I realized that the first 0 is just there because I don't know, it's the same down here. So this is not 001x, this is 01x, but it's yes, it says the same thing. But I got mildly confused, to say the least. But yes, X location 2 and 3, which is right at the start of memory. So if we tune our thing here to only look at... Let's only look at those 3 bits of memory. First 3 bits of memory. I don't know, will that print 3 or 2? Maybe 4. I don't know. 3, okay. So... Also, the memory readout is the readout before the instructions. No, so it's all of this. And then, as it's doing the instruction, it prints the instruction name. So I should really... Let's move that to be at the proper place. There we go. Easy for reading. Let's try this again. C5F5, C5F7, C5F9, yes, with another store X, C5FB, which has another store X, C5FD, which is JSR, going to subroutine, and we're gonna end up on allegedly C72D. I'm fucking impressed. That means because this address is 2 bytes long, which means that my bit juggling is somewhat working. It's not bit juggling per se, but it's because of the endianness of the system. You have to read shit backwards, and it's a nightmare to get your mind around it. C7-2D. C7-2D is a no-op. And then we run into C7-2E, which is just unknown because I haven't implemented it yet. So yeah, and that's why I have all of these tabs open. This one is for finding it and potentially just getting to it and server, and potentially get some pseudocode to do it and check what registers are affected and crap. And whereas that's not available and it's just read like this and doesn't give a page, I only have the 65.2 sheet here, so I can just jump to any operation here or just type in operations, quite frankly. Let's jump to PHA, which is push A. Stack instructions, yes, here they are. TXS, TSX. Oh yeah, those are stack. Transfer X to stack pointer. Transfer stack pointer to X. But you can't transfer it to Y. Limitations of the day, I guess. Push A, pull A, push P, pull P. So you can actually pull and push the processor status with flags onto the stack, if need be. And as you see, yeah, roll. There's no text for this page. Let's check out roll here. Rotate left. Oh shit, yeah. The rotate left includes rotating through the carry bit. And that's why I kind of just want to somehow integrate the carry bit into the number. It's irresponsible, it's unpredictable. It won't work right when it actually overflows. So let's not do that. Oh yeah, here's the memory map if I need it. But yes, what we're gonna do is implementing our codes. And, this file is a lot smaller now. Let's see, analysis is 317. Still quite a bunch. But where? There. Yes. I guess TXS is, yeah, it's implied. All of the transfer ones I'm probably gonna define in like a block, which I'll do now. So I have TAX, let's do TAY, which is 0xA8. That's not the 8, that's a 8. TX, no, TA, transfer A to Y. Implied. Was it A8? 10, yes. Next one, TSX, 0xBA. No, TXS is not what I want TSX. It's a big difference. Also implied. What's next? 0x8a. TXA. That does exist. Somehow I defined that and not implemented it. 0x 9a. Lots of a's. Also with the TXs. Oh yeah, I did define a bunch of transfers, but I didn't implement them. I remember now. 0x98. That was all for the transfers. TYA. Also implied. Now we need to define all of these. Preferably TXA with TYA. I'm just gonna grab this and put it at the top because order doesn't matter. And I'll hunt down other T functions. TSX, TYS, TSI. And I did see that function that I missed. Oh yeah, sorry. TXS, yeah. Maybe I did define all of the T once. Maybe I did. So we have tax. We don't have tax. We don't have any transfers today. We only have transfers between Y and S and YA, SX, YS, SY. SY, XS. Just checking for duplicates. I'm sure the program would not patch me for having duplicates anyway. Python duplicates entries in list. Is that possible? Find and duplicate entries in dictionary. Right. Thinking through it, the dictionary I'm using should not even be able to initialize if it has two of the same opcodes defined, because they will both take up the same key, and then the keys are not unique, and the concept of the dictionary falls apart. It's like you would use the letter 4 to define 6 different kinds of pages. See what I mean? Ah, I didn't know I can do that. Apparently I can change tab with side buttons on my mouse. let's define tags. Actually, wait, I'll just do the header thing for it, and then I'll look for the rest of the T functions if they are here. Nope. Nope, literally. Tags, what does transfer A to X? Obviously. TX, TAX, self dot the helper functions aren't needed here. Oddly enough. Just finish this functions and this is not going to run properly, I think. TAY function is not defined. Guess we'll define that. And I don't mind that there is no particular order in these files. I can always use Control F, it's no big deal. Actually, I'll raise exception instead of breaking. Processor has an attribute of that thing. So the processor imports the helper, the processor imports the helper, the processor imports the opcodes uses the processor's context because of the self-referencing I'm using, and I don't know what good it's for, but I guess the good thing is that it's all contained in a class and that you can have multiple emulators running in the same program theoretically. So that's one upside. Shut up, dog! Yeah, let's import the helpers in the processor from helper import. Blip. It worked, it ran. It ran fast, long, and it ran further. I think it actually ran further. C5 F5 C5 F7 STX, yes, C5 F9 STX, C5 FP store X, C5 FP store X, yes, C5 FT JSR, C5 FT JSR, C7 2D MOP, C7 to the nope 372E sec 372E, and there you look, because I haven't implemented that yet. So no, it didn't run further actually, which is sad. But yeah, that has cleaned up. The opcodes are clearly the largest part of the file. Holy shit. 253 lines. Helpers are 139. Emulator with the opcode definitions. 324 lines. Maybe I should take this opcode definition and put it into the opcodes itself. Just a thought. It will still be imported into local space, like instantly. Wait, hold the printing press. I need that diagram that's above it for reference. Helper functions start here. Nope. Oh, maybe I should move over the ALU compared to the helpers. That was the wrong. Here's the right. At the top or bottom? Top or bottom? Bottom, because I have to do it at the bottom, because otherwise the definitions don't exist. There's a shelf, let's move that in, let's save, let's update that, so let's get anything. Go to here, remove the ALU compare, throw it into the helpers. Put at the top, why not? Move it in, move to the top, type in gaps. Actually, that's why I had gaps. Let's see if we still run, we still run. Let's see if we can trim out some more crap and put it in another file. The addressing modes. First of all, address mode 5, the relative one, is never used. It's not even defined, I think. I mean, theoretically, it's just looking at it and just deducing that what it reads from the program counter and then adding that to what it reads from the operand and just adding it together, and that is the relative. Logically it's correct, but down here I've defined it as not used on the 3A02. But it was defined in the 6502. So I don't know if I should leave that in there. Like a Frankenstein 6502 with some NES, a NES with some. Basically, the 3A02 is a 6502, but it has some functions stripped out of it. If I'd leave this in and keep all of the stuff of the 6502 except for the essential modifications, like the break not being a break and instead being a no-op, and other stuff like that, it will be like I'd modify the processor to not be a trimmed down 6502, to just to be a 6502 with extra sound processing. So I don't know. Maybe you could maybe if I implemented this correctly, you could write code that runs on this that doesn't run on other emulators. That would be kind of fun. Although I don't know if... Are there even enough states left on the... Like, how many unused opcodes are there? Quite a bunch, actually. You could probably fit an entire... well, the 6502 did fit an entire 2 more addressing modes. 3 more addressing modes, I think. Yes. Into the same 8-bit space. So, I'm not gonna argue it's impossible. Although it might be the case that they did reduce the capability of the 6502 to make room for other functions that does more complex things, maybe. But I doubt it. I don't want to make the opcode files longer. Also, pulling in the address modes and shit in there would not make it a strictly opcode file anymore, so... Meh. Let's implement more functions, I guess. So, we did all the transfer functions, probably working correctly. Do we have all our store Y functions? Zero x is that file? I'm dying here. Jeebus. 0x 8c and that's sty, and that's an absolute, and that's what I use this diagram for, where absolute is 3, and then we have 0x 94. Also store Y, but this time it's 0 page index x. 0 page index x 8. 0x. Where am I? 8 for store Y. 0 page, which equates to 4. Zero x 8e that's a store x function. So I'll finish that on this line, but I'll move it up. That's absolute. 3. Cut. So we have 0x 86 and 8e. 86 and 8e, so now we need 96. I can't read, what the fuck am I reading? 0 page Y, Jesus fuck. 0 page y and 9. What the hell am I doing? I'm just not at the top of this at the moment. Huh. A pattern I notice now. When you store X, you can 0 page index with Y, and when you store Y, you can 0 page index with X. They're cross-linking, so I don't know, maybe you can use that for some fancy indexing magic. But I guess we could sort this. Plop, plop. It's already sorted. Ah, Jesus, I do kind of want to sort all of these, but kind of not. Although LDX and LDY have wildly different parameters. Let's see here, that's no. That's load X, and then with that's this load Y until the red. So we have 0 page, 0 page, 0 page Y, 0 page X, yes. Absolute, absolute, absolute X, absolute Y. Needed. Okay, so that's why two functions differ from each other. The address amount, that is. So yeah. I'm sweating, fuck. Damn it. Ugh. Disgusting. I'm sure you agree. Why is there highlighting text? Please. Psychoblyat. That was an intentional mispronunciation. Anyway, we have our ands, we have our loading. Oh, sorry for that. We have our ands, load A, and with carry, add with carry, not and. Store A, load X, load Y, transfer functions, store X, store Y. Bunch of miscellaneous functions. We have SEI. Control F, SEI. Yes. Do we have SED? Probably none, don't. No. Let's define SED. What is SED? Hello? This server is slow as fuck at the moment. Set decimal flag. Set the decimal in the processor status registry. Now, the funny thing is that the 3A02 doesn't have decimal functionality, but it still has these. It still has that bit in the register, and you can still read and write. You can still set and clear and read that bit. So it's essentially one bit of free space that you can use, and I bet someone will. So I'm gonna have to implement that. No worries, it's simple. Let's just put at the bottom here. Def sed func self operation print sed return true and yeah, sets to decimal. So I wouldn't think I would need that. Is it even defined? No. Def set decimal self well self dot set bit. Which bit is it? Which bit is it? What? We have 0, 1, 2, 3. Third one. Where are we? Here. 3. And then we can basically copy that. Paste that. Yeah. So there's probably a CLD as well. That's, I assume, going by the naming scheme. Clear decimal flag, what can I say? CLD func self operation print clear decimal self dot set decimal false return true. Also the return true, maybe I've talked about that, that's for actually increasing the program counter with set amount told by this steps here, because I did a clever little observation. It should be quite obvious when you're talking about address modes. That is, depending on the address mode you choose, a certain amount of bytes will be used as both the opcode and the data. And in most cases it's 2, in some it's 3, in some it's 1. It's directly related to the address mode, I notice. I just have another little array here that basically has the index of the nodes up here and how many steps the program counter should take. So in implied mode it's steps 1, in accumulator it's steps 1, because they're both implied, but they return different things up here. 3 is absolute, so it requires 2 data bits, and the opcode, so that's 3 steps. 4, which is 0 page, requires 2, which is 1 parameter, which is, well, it's going to wrap around the 0 page because it's only 256 states in 1 byte, so yeah. And then we run into the crux about number 5 and 9 and that crap. Let's not go into that. Let's go back to implementing functions. Let's see now if we have... Also, I brought up the chat here for no good reason, and I put it to stay on top. So theoretically I could hide it in some corner where it doesn't actually bother me as much. But where I will actually see it. Because it's happened on multiple occasions now. that I have like closed down the stream and I closed down the browser, and then I see the chat like there behind. It's like, hey, what are you doing? It's like, I didn't see that. Sorry, man. Sec. Do we have that? Nope. Let's implement it. Sec func self operator. Oh, technically it's an address. Okay. Not sex, sec. Stupid. Implied, I guess, but what does set carry? I can make a cup of tea in that time. Fuck's sake. Yeah, set carry. Why did I even check? While we're at it, we'll define the CLC as well, clear carry. I'm not even gonna look it up because I'm dead ass confident it's gonna be the same naming scheme. If not, then I'll pull my hair out. Actually not, I like my hair. It takes so long and it's painstaking to grow hair. Seriously. Why do I keep writing true and false with big letters? Stop it! There we go. Evil demons have been eradicated. SBC. Let's check what that is. Subtract with carry. Immediate survey checks, absolute X. Yeah, that's quite a lot here. Do we have a SBC? We do. This is not correct, the way I'm doing it. Subtract with carry results are dependent on the settings on the decimal flag. In decimal mode, oh yeah, that doesn't fucking matter. There is no way to subtract without the carry, which works as an inverse borrow, i.e. to subtract you set the carry before the operation. If the carry is cleared by the operation, it indicates a borrow occurred. How do I like define that in a good way? I mean, here's my generic ALU compare function that I basically call when I want to do stuff on the A register, and it basically updates the relevant flag, the -0 and overflow flags. The carry, however, Wait, what's the difference between the overflow and carry flags? Don't they do the same thing? 6502 overflow tag help. Okay. It's basically the 9th bit. Hey. What's the difference between an overflow and a carry? Overflow vs carry, yes. The difference between carry and overflow. Pick list, yeah, this is probably relevant. Carry is generally used for unsigned arithmetic, and overflow is used for signed arithmetic. I don't want to do this right now. But the function is flawed, it needs to change. Tell you what, we'll modify this code to do some subtraction? No. We'll modify this code to do some subtraction. So we're gonna load 42. Shit, I fucked up. We're gonna negate 12. We should get 30. I'll put it at that position. Did it say? 2F. You who can actually fluently read that will know that. What the fuck? Oh. It's 42 in... Maybe I should just do this. 66? Are you serious? Oh yeah, I should... 2A, yeah, that sounds better. Let's use that. 2A. And C, sure. And we've got 1D. $29. Why isn't that 30? Is it because of the weird signed and unsigned arithmetic? Also, here's where I got the just using the hexstone theorem. I just implemented a piece of stack code up here. So it's defined here, straight in the file. I have two of them. One of them that uses the stack to check if it's working somewhat, and one that just prints some numbers. You may actually want to run that, so you can see what it does. P.memory, and you can see that shit. I'm confused. Zero, 2. So it should load to 0x 0200 and forward. You see that? Nope. It's not working. Yay! Why isn't it working? When the ROM starts, am I resetting properly? I'm probably not. Because I'm disabling resetting and running the thing from a known state and running from inside of itself. Okay. When here I started at the C thing, but I could literally start it at 0 and have the reset pulled high at the beginning. Then it will reset and it will jump to the reset location, which I've made it pad the ROM to actually put those last 2 pieces of bytes there. I guess. What does it even do? It's called numbers. Was it this one? One, two, three, four, five, six, seven, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, there's the same. So it's this program here. Load a story, load a story, load a story. I have a feeling we're not executing that. We're executing a load of breaks, that's what we're doing. We're basically sliding through no plan there. But the break causes... The break should cause an REQ interrupt, why doesn't it? Hello? Shit like this that you need to watch out for. It does set the manual IRQ, and the manual IRQ should be a reason to trigger here. So either if IRQ is in or manual IRQ is on, which it clearly should be because the brake is firing, it should print IRQ triggered, but it doesn't. Ah, because it's already in interrupts. It's already disabled interrupts. Okay. Let's slow this down so it runs a lot slower. And let's terminate it and see what it did. Come on. What the fuck? What is this? Syntax warning. Import star only allowed at module level. Warning. Yeah. I want it to be contained to that. Why does it warn me? Let's Google that and see if we can actually disable it by setting some variable. The section about nested scopes. Yeah, figured. Now someone's calling me, hold on. What do I say? Shit has happened and I need to go. Pronto. Goodbye.